have studied in laminar flow the equation of shear stress, viscosity as well as the pressure difference between the two ends of the pipe. Now we'll apply these equations to solve problems related to laminar flow. So let us solve a problem on laminar flow. So we have a problem over here which says that an inclined pipe of inclination 3 degrees with the horizontal is 2.5 kilometers long and carries oil of specific gravity 0.859. So what is actually given to you? There is a pipe which has a length of 2.5 kilometers and it is inclined at an angle of 3 degrees to the horizontal. So let us draw this entire pipe which is carrying on an oil of specific gravity 0.859. So let us consider this as horizontal and the pipe is inclined at an angle of 3 degrees and it is actually 2.5 kilometers long. So 2.5 kilometers, so this becomes 2500 meters. So it is inclined at an angle of 3 degrees. Now what else is given to you? What flows through the pipe is oil which is flowing through this pipe. Let us consider this as section 1-1, this as section 2-2, which is actually at a higher level from an initial level 1-1. Now oil is having a specific gravity of oil which is given to you as 0.859. So the density becomes 859 kg per meter cube. So the density is given to you. So now how do we get the density over here? That is a specific gravity of any liquid is equals to density of that liquid upon density of water. So the specific gravity is 0.859. So the density of a liquid will be upon density of water. So the density of liquid is equals to 859 kg per meter cube. So that is the density of oil which we have calculated since our liquid is oil. Now this we have calculated, this we have written by reading the first statement. Now next it says that the flow of oil is being 60 liters per second. So the next thing which they have given us is the flow of oil, that is a Q is equals to 60 liters per second. So this is 60 into 10 to power minus 3 meter cube per second. That is the flow of oil. Now next thing which they have given to you is the kinematic viscosity. The kinematic viscosity is 0.2 Stokes. So that is value of nu has been given to you, and determine the pressure difference between the two ends assuming the diameter of the pipe is 30 mm. So this is what is given to you. So let us write down the kinematic viscosity part, that is nu is equals to 2.2 Stokes. But we will calculate everything in SI unit. So this will become 2.2 into 10 to power minus 4 meters per second, meter square per second. Now next part which is given to you, that is the diameter of the pipe is equals to 30 mm, which is equals to 30 into 10 to power minus 3 meters. Now everything we have written in this format. Now what we have to actually calculate is what is the pressure difference between the two ends. So we have to find the pressure difference P1 minus P2 between the two ends of the pipe. Now let us calculate the pressure difference. Now we know what is formula for pressure difference. So we have to calculate over here what is difference in pressure across two ends, that is P1 minus P2. So we have drawn the diagram, that is a pipe which is inclined at an angle of 3 degrees, and we have to calculate P1 minus P2. Now technically speaking, the difference in the pressure over this entire length, we know actually that is equals to P1 minus P2 is equals to 32 mu u bar upon L, 32 u bar mu L upon d square. But now this formula is only applied if the pipe is horizontal. If the pipe is horizontal, but here the pipe isn't horizontal, it is inclined at an angle of 3 degrees. So we cannot apply this formula in this entire problem. So that is why what we have to use Bernoulli's equation across the two ends of this entire part. So now for a laminar flow, Bernoulli's equation can be written as P1 upon rho into G plus V1 square by 2G plus Z1 is equals to P2 upon rho G plus V2 square by 2G plus Z2. Now, this was an equation for an ideal fluid whose viscosity is 0. But since we are learning laminar flow, it has some viscosity, that is a real fluid. Here, you will have some head loss, that is HL. Now, this head loss, which we have studied, this is given as 32 mu u bar L upon rho G into D square. Now this is the head loss which we have studied. Now in this part we don't know the values of P1 and P2 which we have to calculate. We also don't know what is a V1 as well as V2 square. Similarly, we don't know what is Z1 as well as Z2. Now, first let us calculate the value of HL, then we'll calculate the value of Z1 and Z2, then we'll calculate the value of V1 and V2. We'll substitute in this entire equation to get what is the difference in the pressure. So now, to calculate HL, what we need over here is mu u bar L rho G into D square. So the things which we have over here, let us check out what are the things which you have. That is, first you have what is the value of D. Next thing which you have is the value of rho. You have value of G also. So these things we are known, but we don't know the entire denominator except L. So we have to calculate the viscosity, we have to calculate the velocity. So let us calculate the viscosity and velocity. So over here, let us calculate viscosity. So viscosity, this is the dynamic viscosity, will be equals to rho into, so this will be equals to, rho has a value of, that is 859 kg per meter cube, and the value of nu is equals to 2.2 into 10 to power minus 4. So let us substitute this. So this becomes 2.2 into 10 to power minus 4. So this will give you a value of 0.194 poise. So we have calculated this in terms of poise. If you want to convert this into Newton second per meter square, this will be 0.019 Pascal second. So that is value of viscosity. So in this equation we have calculated what is viscosity. Now let us calculate what is velocity of the fluid, that is the average velocity of the fluid. Now in this entire part, if you can see over here, the diameter at section 1 and diameter at section 2 is same because the diameter is given to you as 30 mm. So now let us calculate what is the average velocity. So the average velocity u bar will be equals to area, q upon area of cross section. Now q, which is equals to 60 into 10 to power minus 3, diameter is equals to 30 mm, so that is pi by 4 into 30 into 10 to power minus 3 the whole square. This will give us a value of 0.8488 meter cube per second. Meter per second, not meter cube per second. So we have got the value of u bar, that is 0.8488 meter per second. Now, so from this equation, we have calculated the third value or the last value also, that is value of u bar. Let us substitute all those individual values in this equation and let us calculate what is head loss. So HL will be equals to 32 u bar L upon rho g into t square. So this is equals to 32 into u bar 0.8488 into mu, which we have calculated 0.019. This length is 2.5 kilometers, that is 2500, upon rho, which has a value of 859. G is 9.81 into 30 into 10 to power minus 3 the whole square. So the head loss will be given as equals to 16.92 meter of oil, or this is the head loss in that entire part. Now we have calculated what is value of HL. Next thing we'll calculate what is value of V1 and V2. Now, technically speaking, if you see this entire diagram, the diameter is going to remain constant. If the diameter is constant and the flow rate is 60 liters per second, across the both section, both velocity V1 and V2 will be same, because the diameter at section 1 is equals to diameter at section 2. So let us represent this in this equation. So what we get over here is V1 is equals to V2 since D1 is equals to D2. So we have taken care of velocity. Next we'll take care of Z1 and Z2. Now let us check out our diagram. So in our diagram we had drawn this, that it is inclined at an angle of 3 degrees to the horizontal and it is 2.5 kilometers long. So what we'll consider, that is section 1 is the reference line, hence Z1 is equals to 0, and section 2 is at some height above section 1 whose hypotenuse becomes 2500 and the angle with the horizontal becomes 3 degree. So this entire length is 3 degree. What we need is the vertical length. So let us draw this diagram for Z1 and Z2. So this is the hypotenuse. So this is 2500. This is value of Z1, which is equals to 0 because we are taking this as the reference line, and Z2 is vertical distance at some height. Let us calculate at this height if the angle of inclination is 3 degrees. So over here Z2 will be written as 2500 into sine of 3 degrees. So we have calculated the value of Z1 and Z2 also. Now let us substitute this in the following equation. So Z2 is equals to 2500 into sine 3, which comes out to be 130.8 0.83 meters. So we have calculated the value of V1, V2 and Z1 and Z2. Now let us substitute in the equation of Bernoulli's equation. So now we know that is equals to Bernoulli's equation is equals to P1 upon rho g plus V1 square by 2g plus Z1 is equals to P2 by rho g plus V2 square by 2g plus Z2 plus HL. Now over here the value of Z1 is equals to 0. The value of Z2 we have recently calculated, that is equals to 130.883. Now over here the value of V1 and V2 both are same, they are on the either side of is equals to sign, so they will be cancelled. So we can write this as P1 minus P2 upon rho g is equals to 130.83 plus HL. Now value of HL, which we have already calculated from the previous section, that is equals to 16.92 meters. So this is 16.92 meters. So hence P1 minus P2 will be equals to 859, which is value of density, into 9.81 plus 130.83 plus 16.92. So if we evaluate this value, this comes out to be P1 minus P2 is equals to 1261.08 kilonewton per meter square. So this is value of the difference in the pressure. I hope you have understood. To solve a problem of a pipe related to laminar flow which is inclined at an angle of 3 degrees to the horizontal. Thank you.